Hey everyone, Tommy here, current Director of Development for Lava Lab, and we're coming at you with a new video for the upcoming Lava Learn module, Recruiting and Networking. Today, I'm here with Connor, and we're going to be doing a mock interview, sort of just walk through an example problem, how you should be asking questions, solving it, etc. And then afterward, we're going to just have a quick debrief and just give overall tips and everything. Connor?
Yeah, hey everyone, I'm Connor. I was studying computer engineering, computer science at USC with a minor in music production. Graduated last May. I was in the fall 2017 cohort, and last year I was director of development. And I'm excited to be here. So, yeah, ready to get started.
Perfect. Thank you for coming out. So, without further ado, we're just going to get straight into it. Connor, given a string S, find the length of the longest substring without repeating characters. Right below it, you can see some example inputs and outputs. I'll just go over the first one really quick. If you had ABC, AB, C, B, B, the answer we'd be looking for is 3 because the longest substring without any duplicates is ABC. And you can kind of get the gist of it by looking at the other ones. And so, yeah, the floor is yours.
Yeah, sounds good. Okay, let me just write out some other examples and think about this a little bit. So a couple clarifying questions. First, do we have to worry about like special characters like question marks, dashes, spaces, any of that?
No, nothing of the sort. The input is just going to be letters.
Okay. What about like capital letters? Are capital letters, is like a capital A considered unique compared to a lowercase a?
For the sake of simplicity, you can assume that the input is only going to have lowercase letters.
Only lowercase letters. Cool. Let's see what else. Do we have to worry about is what's like the longest string that you're gonna give me?
Let's cap it at 100 characters.
Okay, cool. I guess for a brute force solution, and maybe let me type out some pseudocode here. I'm thinking about basically just for each character, um, looking at each possible subsequence. So we'll have another nested loop here, and basically just seeing if we've keeping track of each character that we've seen in some sort of hash map. And if we've already seen that character, then we know, or if we haven't seen that character, then we can keep sort of expanding the um, the substring until we end up seeing a character that we have already seen. So if we're looking at this, for example, we'll start here and then we'll go to here and see W. And so far it's all unique. And then when we see W again, we know that so far the longest substring we've seen is PW. And then we can move on to the next substring starting at W, and then we see W again. And then we'll go to this substring here, starting at W, expand to K, expand to E, and then expand to W again, and then we'll have a longest substring of 3. What do you think about that solution?
Oh, that seems pretty reasonable to me. Why don't we get started and see how the code comes along?
Yeah, that sounds good. Okay, first I'll just do a check for if the character or if the string is empty. So if it's equal to 0, then we'll just return 0 because we know that the shortest possible or the longest possible substring is capped at 0. Next, I'll just keep track of what our answer is going to be. We'll assume it's 0 at the beginning, and then we'll set up our loop. So we'll do, since I want to have the indexes, I'll use the range function. So we'll loop over the entire string, and then we'll keep track of a dictionary here, which tracks all the letters we've seen for the specific substring we're looking at. Next, we'll do our inner for loop. Then here we want to check, why is this complaining?
I think you're just missing the in keyword.
Yes, thanks. Okay, now so we want to see if, so I is the start of our substring, and then J is sort of what we're scanning across the string for. So we want to see if J, we've already seen J. So if J is in scene, or if J is not in scene, J not in scene, then we can recalculate whatever our longest is. So we can do longest equals j minus I plus 1, because if j and I are both 1, then 1 minus 1 is 0, but the longest substring would be 1, so we want to add a 1 here. And then we want to compare that to the longest. And if it's bigger than the longest, then we'll use this value here. Otherwise, we'll just maintain our current longest that we've been looking at before. And then we'll make sure that we add this current character that we're looking at into our dictionary. And then if we've already seen this character, then we don't need to continue with this loop anymore, so we'll break. Let's see, let me just go over my code and make sure everything makes sense. So here we're looping over.
I'm just going to put these on separate lines for readability real quick.
Okay, sure. Yeah, so then this would be, and then we don't need this. So we're looping over the string with a starting point. And this is meant to represent the ending point, represents end point. And then if we haven't seen the character at the end, recalculate the longest. Oh, I guess that's here. Let's see. Yeah, that looks good. If we've seen character already, break and move to new starting point. Cool. I feel pretty good about this. I guess I'll just start. Yeah.
Oh, yeah, I was just going to say, first of all, I think you want to check your return statement there.
Oh, right.
No, but this looks all good to me. Why don't you, I think there might be a bug in there. I'm not sure. So why don't we run through some example? Why don't you run me through some test cases and we'll see what.
Yeah. Cool. So we can use the ones that we already have up here. Yeah, so this should output 3, so should this one, and then this one should output 2. So let's run. Okay, so yeah, it looks like on the right we're not getting the right values, so let's look at what's going on here. So we're looping over this, and we're keeping track of the values we've seen already. And then if j, oh look, so we're using the index here and not the actual character. So we're trying to see if this specific character is not in what we've already seen. So I think that's what our issue should be. It doesn't look like anything else. So we'll run this again. So this one is still outputting a 2.
But why don't we like take one of the test cases and just kind of maybe step through like the first loop or something and see what's happening.
Yeah, sure. So
speaking it out.
Yeah, so if we're looking at PWWKEW, this example here, this is the one where we're getting the wrong output. So I and J are both looking at P at the beginning, and then J goes over here, and right now in scene, both P and W are in this dictionary here. So we'll expand J over to W, the next W, and then over here, if SJ not in scene, that's not true, so we go here instead, and then we break. So we'll go back to the top here. And then so far, our longest is 2. So now at I equals 1, we're starting at this W here, and J equals 1 as well, so we go into here, and then it's not in scene, so we recalculate the longest, but in this case, it doesn't look like it's going to be the longest because J minus I plus 1 is just 1. So let's see, this all looks right, and then we'll add J to, or S of J to the scene. And then when we expand again, we'll see that we've already seen W, so we'll break, and then we'll start at this W here. So now I is 0, 1, 2, and J is 2 as well. We're starting at W, we add that, and our current length is still 1, and then we'll expand again. K we haven't seen yet in this substring so far, so yeah, we can keep going, and our current length, J minus I plus 1, should be 2. And then if we go to E here, this is where it should be outputting 3, but it looks like it's not. E is still not seen, so we go in here. So let's see what's happening here. Maybe, I think maybe something that makes sense is just to sort of print out whatever this is here. And then we can also print the actual character that we're looking at.
Why don't you hide the other two inputs and just comment?
Yeah. Cool, so, okay, -3. Oh, okay, there it is. So our issue here is that, oh wait, no, is it? So for some reason we're getting negative.
I think just to kind of give you a hint,
Yeah,
it kind of has to do with what is it? Exactly what you're looping over.
for I in range length of S, for J in range length of S. Oh, that's right. So we don't want to be, so for our right character here, when I is here, we don't want to be starting back here. We want to be starting up here. So I think for our range here, we want to do I to len S. I think that's should be solving our issue. We can keep those print statements. Yes, so this final output here, 3, that makes sense. So go back and test the rest of these. Cool, so this outputs 3, this outputs 2, or this outputs 3 as well, and then this one outputs 2. Yeah, I think I'll write a couple more test cases just to see some of like the edge cases as well, and make sure those are running correctly. We'll do one that's just the empty string, which should output a 0. And then we'll do one where it's all just one character. And this should output 1.
Oh, perfect. So can you tell me a bit about the runtime of this algorithm?
Yeah, so let's see here. We have, just to check here, creating a variable. Now we have a loop here. That's going to run for O of n time, if n is the length of the string, the number of characters. And then here, we have another loop, basically over the string as well. It decreases, but it ends up being O of n as well. So I think our overall runtime is going to be bounded above by O of n squared.
All right. And what about our memory or a space-time?
Yeah, so let's see. In terms of space, we have this string array that's coming in, which is just O of n, and then we create a dictionary in every loop, but it gets recycled each time, so that's going to be O of n as well. So I think the overall memory complexity is also going to be O of n.
Cool. So this is obviously a very straightforward solution. You get the answer pretty quick, but it's not optimal and squared. How do you think you can improve upon this?
Yeah, so I guess if we're looking at O of n squared right now, and we want to improve our runtime, we are going to have to go towards something like a n log n or even O of n time. So let's think about how we can do that. Yeah, let me just try writing some stuff down. Yeah, so I guess when we're looking at these substrings, right? For example, looking at this first example up here, the ABC one.
Mm-hmm.
When we scan through this and we see the A again, we start back here. But we already know that B and C are unique before getting to this A, right? Because the loop is already able to get all the way from A to B to C. So when we start in our current solution, we go from B to C again, but we already know that these two characters are unique, and that's kind of just unnecessary work that we're doing. Um, so my intuition is that a better solution would be to have sort of two separate pointers that are keeping track of the start and beginning, kind of like how we have now. But instead of going all the way back and sort of retracing the steps that we've already taken and sort of wasting time, we can just increment the left and the right separately based on whether or not we've seen the character or not. And that should be able to give us O of N time.
Yeah.
How does that
So
sound?
if you don't mind, can you kind of like try doing like an attempt at just like drawing what these two pointers, or the idea you're trying to talk about, since you don't have like a whiteboard or anything?
Yeah, sure. I think, yeah, let me go through this solution. I'll just make it a little bit smaller. Um, but so I think in my mind, what makes sense is for the first pass, it's sort of just similar to how our current solution is. So it would go from A to B to C, and then it sees A again. So instead of just starting over from B and going from B to C to A again, what would make more sense is to just move this left pointer that's looking here over to the B. So yeah, there we go. And then we already have the A, or the right pointer looking at A here. And then so we continue to move that right pointer over. And then so we've seen B again already, so we'll move that over here. And basically we just use sort of like a sliding window to keep track of like the longest unique substring that way.
Okay. So do you think that this is something that you can build upon off of your current code, or are you going to just write the function from scratch again?
I think I'll start writing it from above, or I'll start writing it below here, and then I think there are parts that I can definitely use, so
Okay.
I'll just pull those in um, when I think I need them. So yeah, so we'll start with this again. We're just checking for the length of the string. If it's 0, then obviously we just return 0, just like last time. And then we'll keep track of a left and right pointer. So I and j, we'll both start them at 0, which is at the beginning of the string. We'll have that longest variable again. And then we can keep track of a dictionary outside the loop. So now, in this case, it makes sense to use a while loop because we already like have our indexes defined out here. So while I is less than the length of the string and j is also less than that length, that's when we know we need to stop once basically we've looked at all the characters.
Mm-hmm.
Cool. So now we need to check sort of the same thing. If the right pointer, if we've already seen the character that's at this right pointer, so if sj not in scene, then first we'll make sure we mark that as seen. So we'll set that to true, and then we'll move that right pointer over and then calculate our longest again. So, oh yeah, we can do this in 2 lines. So if j minus I is longest, and because we're not going to add 1 this time because we're actually just incrementing j before we recalculate the longest, so that's basically the same thing as just adding 1 here. J minus I is greater than longest, then we'll update that. Otherwise, well, I guess otherwise we don't do anything. Okay, so in the case where we do see, or where S of j is in scene, that means we've already seen the character that's at the right position. Then we'll increment, or that means that so far we have, or that means that the character on the right position is the same character as the character on the left position because we've gone this far and still haven't seen it. We've only seen unique characters until this specific point. So sort of go back to the example here just to make that clear. We'll be at A, and that's where I is right now. So let's put I there. And then J will also be there, and then J moves here. Still unique. J moves over here to C. It's still unique. And then when J is here, we've already seen A before, and we know for a fact that A is also going to be at I because all these other characters before were unique. Otherwise, we would have stopped sooner. So what we can do here is remove that character from our scene, basically just by setting it to false. And then that also means we need to change this to make sure that this is, or so not, oops, or not seen as J. So basically, that the character, if it's false there, that's the same thing as like if we haven't seen it. And then we'll increment I here because we want to move over one at this point. We want to move our sliding window over from the left. Okay, yeah, let me just go through this again. I guess we can remove everything above here. So these are our starting indexes, our indices. Tracking the longest, tracking which characters we've seen. And then we'll basically loop until both pointers are past the string. So in this case, we haven't seen S of J before, so we'll mark it as seen, and then we'll recalculate the longest substring we've seen so far. And if we have seen it, if we have seen S of J, then we'll unmark as seen, and we'll increment the left pointer. Yeah, I think that makes sense. I'm ready to test again. Does that sound good?
Yep.
Cool. So yeah, let's just run all these test cases and see. So this one outputs 3 here. This is outputting 2, 0, and 1. So yeah, that looks good.
Perfect. And so just sort of wrap up the problem and everything, you probably know what's coming, but runtime.
Yeah, so this time we don't have a nested loop, which is nice. So let's see. I guess we're having 2 pointers that are scanning across the string. So this J basically scans across, and then the I scans across as well. So since we're having 2 separate pointers loop across, I think the overall runtime is going to be O of 2n, or basically just O of n.
And does our space-time complexity change at all now?
For space complexity, we have this dictionary here, and this is a global dictionary across the whole loop. We're not using any other arrays or variables, so I think our space complexity is also O of n, just like the last solution.
Nice. So just cutting down on that runtime very nicely.
Yeah.
But yeah, I think that wraps up the problem itself and the first portion of this whole video. Good job. That was just great on all parts. So now we're gonna sort of debrief a bit. I'm gonna give Connor some feedback. In terms of the pre-coding, so before he even wrote his first line of code, some of the things he did really well. He asked clarifying questions, and that's probably one of the most, if not the most important thing that you can do in your interview. Because if you don't ask clarifying questions, that's an immediate red flag. Because even if the problem seems really easy or it seems like you don't need to clarify anything, you just want to show, you want to demonstrate to your interviewer that you're thinking about these edge cases, or you're just trying to clarify it in order to build the most optimal solution. In the real world, a client doesn't come to you, give you a project, and then you just build it on your first try. You're going to ask questions so that you can engineer the best solution possible. So that was really good on Connor's part. He was also thinking about like edge cases really early on, which showed that he's thinking ahead of time. And the other, something else that he did that's very important is just constantly explaining your thought process. You don't want to work in silence, even though if that's something that doesn't come naturally to you. I recommend just practicing it, because while it seems kind of like redundant to just say everything that goes on in your mind. It's giving your interviewer an insight into what you're thinking of and just like how you work through stuff in general. At the end of the day, they're not interviewing you just to see whether or not you can solve a leak code problem. They're interviewing to see what type of worker you would be, how like, and just how you might fit into a team and everything. So you're trying to like not only show that you're a good engineer, but show that you're a sociable one that can be worked with well. Uh,
Yeah, I think just to add to that really quickly, I think that also being able to sort of talk out what you're coding sort of helps yourself too, because you can sort of gut check yourself and say like, oh, I'm writing this line, or I'm trying to do this, and like, oh, am I actually doing that in my code? Like, I think when you're actually describing what you're doing, it sort of helps you like maintain your own sort of line of thinking as well, and like maintain like what like the logic that you're trying to build, I guess, if that makes sense.
yeah, no, exactly. And just to sort of like move on from that, you also he Connor was doing a really good job of just writing down as much as possible. Normally, these types of interviews would be sort of a whiteboard, right? So it would be easier to just sort of like write down everything. But nonetheless, Connor was doing a good job of writing out some extra test cases and sort of just like draw, going through solutions in this like he did with the I and J pointers, just visually showing the interviewer like what's going on in his head. And then you also just want to present your solution in pseudocode or like just talk about it at the very least and get some sort of feedback. Because if you're about to do something very wrong, your interviewer is going to call you out and just avoid anyone's time getting wasted. So it's just very important uh, to be treating the entire process as a conversation more than anything, right? There should be a lot of back and forth going on. Then with regards to the code itself, as we kind of already hit on, you want to be speaking as you code and like sort of explaining what's going on in your head. Again, Connor was doing that very well. Leaving comments and everything so that when you um, get back, when you like maybe you write a solution and then later on in the interview, your interviewer wants to like hit on that again, and then you've already forgotten exactly what that line does. You want to be leaving some notes for yourself so you don't catch yourself off guard at any point. Um, and then also never assume that the test cases they provide you are enough. Again, you want to demonstrate that you can like think of ways to try to break your code, and not only that, just you want to go kind of through the debugging process yourself. Again, Connor did that very well. Like in the first solution, he was stuck on the second for loop for a bit, and by drawing up some more test cases and writing some print statements and everything, that was honestly very good on his part. He's showing me that he knows how to debug. These are the type of thoughts that are going through his head when he does so, and that's the type of person you want on your team at the end of the day. I don't know. Do you have anything to add to all of that?
Let's think. Yeah, I think print debugging is going to be really useful, like especially if you're in a CoderPad environment where you can actually run the code. There are some interviews where they don't, like you can actually run the code that you're writing, which is can be more difficult. But yeah, print debugging is definitely the move there. Like if you saw in that last one, like I was getting negative answers for the longest, and like obviously that's not something you should be getting, and I was able to figure out from there that like something was wrong with like one of my if statements.
Yeah,
Uh,
exactly.
yeah.
And just another thing, so what you might have realized is that Connor first gave like a brute force solution, and then we optimized upon that. While maybe he had seen this problem before, maybe he was able to think of the sliding window one on the spot. My recommendation is unless you like are completely sure that you can like give the optimal solution on the spot there, I would recommend just getting the brute force one out of the way and putting it on there. Because what's more important than anything else is just presenting a solution and just sort of presenting an example of yourself working through a problem, whether or not you get the right answer. Because what can happen is that like you from the very beginning try to implement the most optimal solution, you can be getting stuck on stuff, and then you just end up spending the entire time of your interview just debugging and not really showcasing anything that the interviewer is looking for. Instead, if you sort of just early on just be like, okay, brute force should come pretty quickly. It's normally going to be some sort of n squared algorithm where you just using a bunch of loops. Um, if you can put that on the paper, it also just gives the interviewer a natural place to work off of like, okay, now improve upon this. And just overall, it gives a lot of structure to the interviewer, to the interview itself, and like just sets you up to showcase yourself in a positive light.
Yeah, and I think to add to that too is sometimes the interviewer, if you sort of describe a brute force solution, um, but not necessarily code it, like sometimes the interviewer will say like, oh, okay, like can we try and find a better runtime before you even have to code it? And so that way, like maybe if you haven't like figured out the best solution right away, that's something that you can work through with your interviewer before necessarily like going and actually implementing something, which can be useful as well.
Yeah. What you'll see, or at least what I've experienced a lot of the times, and this isn't necessarily true for all interviewers, because some interviewers are definitely not the most empathetic of people, but lots of them are on your team for sure. Like, if you just like, don't be afraid to ask to ask a question of like, oh, is this the right syntax, or like, oh, honestly, like I'm kind of stuck. Can you give me a hint? More often than not, they will be happy to sort of like push you in the right direction, and they're not trying to penalize you for anything. Again, from their point of view, they're trying to just see if you're a good fit for a team, um, and in a real life work scenario, you're going to be asking people for help. So again, just don't be afraid to if your interviewer needs to kind of like help you along or anything. So moving on, some from the discussion phase of this, where we were talking about space time and runtime, the only thing I really have to say about that, again, Connor solved it perfectly well. He hit on both of them. You just want to be prepared to talk about like the trade-offs between space and runtime, as well as you. At the end of the day, there's no way around it. You just have to know your runtime. You got to know like your sorting algorithms and your data structures and how like using different data structures can improve in some area, but uh, not improve performance in other areas, right? Um, what else? So optimization. So if you're stuck on how to optimize your code, there's a good technique from the Crack the Code interview book, which if you don't have, I would recommend getting. But there's this acronym they use called BUD, B-U-D, and it's bottlenecks, unnecessary work, and duplicated work. Those are where you are looking to make improvements in your code. In Connor's case, for example, he saw that they were doing unnecessary work whenever you were before the sliding window, whenever you were just like starting at the next letter again, you're redoing everything that you were doing before in terms of calculating the longest string up to that letter, right? So there he was able to identify that problem and make a solution based on that. Um, I don't know if you have anything to add to that.
No, yeah, pretty much that was a good summary of like how we use this sort of framework to like improve on the solution. I feel like in other ways, like if we're looking at like bottlenecks, for example, like that's like a place in your code that like is a big or is like the main sort of point in like that has the most complexity and that's causing like the most I guess like slowdown of your code or that's causing your code to run the longest and then like duplicated work and unnecessary work are kind of the same thing. It's just like work that you're doing again and again when you don't really need to. So like thinking about how you can sort of save an answer that you've already calculated that's like sort of like dynamic programming for example and doing stuff like that can sort of help you lower your runtime even if it's not going from like O of n squared to n it still could be saving you time and that's something that's like useful for things like hacker ranks too where like some of the tests will fail because they take too long but if you can sort of use this framework to like shave off some seconds of runtime then that can get you like to pass those test cases as well.
Yeah. Honestly, like a lot of the times, especially with these hacker rank ones, it can be a matter of like, if I can find some condition that will make my for loop exit uh, halfway into the loop rather than at the end of the loop because they're giving inputs of like 10,000 integers or something, you're just saving a lot of time. So a lot of the times, like even though you might be convinced that you just have like the structure of the optimal solution, what you're missing is just some if statements or some conditionals just to like be like, oh, this lets me eliminate 25% of the like inputs or whatever, right? Another thing that you'll often see in these interviews, we didn't really, this question isn't really a type of question that would allow for this discussion, but well, oftentimes you'll get questions more focused on systems design. And by that, I mean, they'll be like, okay, now we want to prepare this code for production. What are like some weaknesses that you need to work on, or like what would happen if we gave it like an input of 1 million characters? Would it be able to handle that? So for these types of questions, like again, there's no right or they're not looking for a right or wrong answer. They're again just looking for like your thought process on what's your opinion on what should be done, because at the end of the day in this industry everything is a trade-off. But it's important to just sort of know like buzzwords, sort of like load balancing, database sharding, just like be prepared to discuss solutions in that context.
Yeah,
Uh,
definitely.
yeah, and sort of just some general tips, honestly, like don't stress and don't be discouraged. Like my first interview, I interviewed with, well, I'm not gonna like name drop the company or anything, but my first interview sophomore year, it went horribly. Like it was a 45-minute thing. And I remember I showed up and they're like, okay, we're gonna start with a nice, easy warm-up question. It shouldn't take you more than 5 to 10 minutes, then we'll go from there. And I ended up spending the entire interview on that warm-up question. uh Obviously like that's a discouraging experience, but you'll come to learn like every single interview is a learning experience, whether it's a good or bad one. You just are practicing sort of talking to someone and solving code on the spot, which is not, it's something that's difficult to practice on your own, right? So don't be too stressed out. Like not every interview you do is going to be a good one. You'll have your good ones, you'll have your bad ones. At the end of the day, a lot of this is just a pattern recognition or just having seen the problem before. So that's my advice of that. Do you have anything you want to add on to it?
Yeah, I mean, beyond that, like this sort of plays off like not being discouraged or not being stressed out, but like, yeah, having confidence or at least being able to show confidence, even if you might not necessarily feel confident, is really useful. I think just it sort of has like a subconscious effect on the interview, even like over the phone or over Zoom, like sort of just like acting like you know what you're doing, I think can have like a big sort of plus, and like it makes the interviewer be more willing to help you too, because if you're in the interview and you're like, like I really just don't know what I'm doing, like it's harder for the interviewer to be like, oh, okay, like maybe you should try looking at this solution, or maybe try like going towards this direction.
Mm.
But if you like are showing that you're confident, you sort of like feel like you're moving in the right direction, then I think yeah, the interviewer is more willing to like sort of like point you in the right direction.
Yeah,
um
exactly.
yeah.
Oh, sorry, go on.
No, that was it.
Okay, yeah, like just to kind of give a bit more of a concrete example, it's just like if you have no idea what to do, you can either be like, wow, I don't know what to do. That's not very confident. Or you can be like, I kind of have some ideas, but like honestly, I'm not too sure. Like, and you just kind of want to set them up to help you. Again, like those are two normal reactions to not knowing how to do something. But one of them, uh, you're just showing yourself off very differently in those two examples. Like one of them is like, oh, I want to work with this person now. I want to help him out and get to the answer. And the other is like, oh, he doesn't even know what to do. Like, why would we hire him? Type of vibes. Like, and just I don't know. Like in general, how do you want to prepare for these things? Like, people will say you want to leak code a bunch, you want to hack a wreck a bunch, and yeah, practice is very important, but it's not necessarily about just having seen every problem in the world as much as it is pattern recognition, which I kind of hit on earlier. Um, because lots of companies do write their own questions. Like, yeah, there's a bank of them that a lot of them will get, but they'll slightly alter them. And if you can just recognize the pattern and just like recognize when you're supposed to use certain types of data structures, or recognize when a solution should be like recursive versus when are you supposed to be doing a dynamic programming or a greedy algorithm. Just doing that will save you so much time and stress and everything. And it's what it means to be an engineer overall. It's just you're using the tools you have to just create solutions on the spot, right? Um, some other advice, I don't know. You want to time yourself when you practice. It can be very easy to just spend the day doing leak code and just like not really like just doing it, not focusing too much on the time and just taking 2 hours. It is good practice to kind of sit down and give yourself like a 20, 30 minute timer and seeing how far you can get and everything. Do you have anything you want to add, Connor?
Yeah, I mean, I think timing yourself is really useful because at least for my first few interviews, like I wasn't even thinking about time when like they were giving me the question and then I realized like sort of okay, my like 45 minutes are up and the interview is going to end like and that's sort of it. So I think like getting used to that pressure can be really useful for you because I don't know, like it's kind of that's kind of like the unrealistic part of the interview is like you're getting timed because the interview's only like 30 minutes long or only an hour long. And so that's something like you're probably not used to. So definitely like practice that. Like outside of technical questions, I think it's a good idea to also like sort of prep like talking points about yourself and like your projects, like prep your elevator pitch, what school you went to, what major you were, like what sort of clubs you were involved in, just sort of like being able to give a like a very clear and concise summary about yourself. I think those are big pluses, just sort of being able to communicate that well as you want to have talking points for, all of the projects or like job experiences that you have on your resume. I think cracking the coding interview has like a lot of great pointers on how to prepare for that and how to like sort of deliver that as well. I think another thing that's sort of not necessarily like something about the technical aspect of the interview is like coming up with sort of like interesting and engaging questions for the interviewer, not just sort of like, the standard, what do you do? Or like, why do you like this company? Why do you want to work here? I think like the part where you ask the interview questions is like really a great and kind of unique moment to like sort of learn about like the internals of a company and like its culture and also another opportunity to sort of impress the interviewer and demonstrate interest in the company and sort of show that okay you've done your research about the company that you're interviewing with.
Yeah. Yeah, just to sort of give some like personal examples about that last point you made, or just like some questions that I like to ask. I have no shame in just asking interviewers. I mean, yeah, asking interviewers, what don't you like about this company, or like, what would you change if you could change one thing, or like, what's a project that you didn't like, just along those lines, because they're not going to feel offended or anything. Like they're more than happy to talk about that. At the end of the day, they're also just another adult working for a company and are going to give you their honest take on whether or not, on what aspects they like and don't like. People aren't like lying about things like these at this stage. Like they're also humans and they have their opinions on everything. I also like asking questions along the lines of like, oh, like, do you see yourself here for the next 3 to 5 years, or is this a stepping stone in your career for something else? Like, how do you see your relationship with this company um, panning out? And that can give you a lot of insight as to like how people and how the company's employees are treating the company. Like, are people just here to make a quick buck, get some funding and then dip, or are they in it? Are they like passionate about the mission and the product, and they want to be in it for the long run? And that will just kind of tell you a bit about the company culture, if that's something that is and should be important to you. Um, so, sort of to just wrap things up as a whole, just really want to hone in on this idea. Every single interview is a good learning experience. And like, whether or not, like, I've left interviews just like cursing at myself, being like, wow, I can't believe I screwed that up that badly. Like, that was embarrassing. Like, what is wrong with me? But at the end of the day, it was a useful experience. Like, it was just more time that I got to practice talking about code and writing code. And if you have a bad experience, all it tells you is like, okay, I need to go and practice these aspects. And it's a good wake up call. It's better to have a bad experience in an interview than to have a bad day at work that can like jeopardize your job or something, right? Yeah. Do you have anything you want to add to wrap this up, Connor?
Yeah, I mean, I think overall it's like interviews are very stressful in general. Like it's definitely like a nerve-wracking experience for me, like especially at the beginning. I definitely have choked my fair share of interviews as well. But yeah, like I definitely agree that it's like a learning experience, and sort of you naturally kind of get better at it. So even if, you have a couple interviews that don't go so well, you'll naturally become more comfortable at doing something that is pretty weird, honestly. Getting on a phone call and like coding in a Google Doc, it's kind of a weird concept. So yeah, it's definitely something you just have to practice. But yeah, I mean, I wish everyone who's interviewing now good luck. And hopefully like this was helpful.
Yeah, for sure. Again, thank you, Connor, for sitting down with me and doing this mock interview.
Yeah, of course.
Thank you to everyone who's watched. I hope you guys were able to learn something useful. And yeah, that's all from us. This is Lava Learn. Take care.